But just to introduce Tanvi, Tanvi is the anchor on OCC for People+ai, but she's actually a biochemist who moved back to India in 2022 to make a foundational impact.
Good evening, everyone. So let's start with our infrastructure initiative there called Open Cloud Compute. There are three fundamental utilities today in the 21st century that we all use. Those are Bijli, pani, and sadak. But there is this engine, there is this fourth utility today that's actually energizing your business operations. We are using it on our phones. It's actually powering AI and our use cases today. And that is servers and compute. So our thesis is that India today needs Bijli, pani, sadak, and servers. Compute is pervasive, it's essential, right? It powers your operations, your communications, your transactions, your analytics, your AI, it powers everything. So what compute can power is an immense amount of things. But there's a second part to it on the supply side. Compute today is coming in very, very diverse shapes, sizes, form factors. Compute is not one processing unit, it's not one form factor, it's not one data center building. Compute is a palette, and that is what OCC is trying to energize. So Tanuj and others spoke about this, right? All AI is compute plus. We're sitting in an AI boom today. And what this is really doing is that it's showing us, we are basically sitting at this inflection point today where this AI boom is telling us that listen, there are newer types of processing units, newer types of infrastructure that is going to be needed. And this is changing very rapidly, right? If you see even in the next 6 years, there are newer, more innovative solutions that will be coming out. Now, this inflection point is actually driving a need to service a very diverse customer base. Again, not just one customer type of enterprises, but you start all the way from students who want to innovate, developers, small startups, growing startups, enterprises. The compute boom today is shaping how we actually will utilize compute. Now, who's going to use this? Let's look at some numbers, right? India today has the most number of engineers and software professionals. We just heard from Dharmesh, there's a growing, we have the most number of MSMEs today, and that's only growing. Digital India is rising. We consume the most amount of data today. Let's guess how we stand on data center and compute infrastructure today. And these are world rankings. I'm going to maybe ask for numbers, but okay, I'll give it away. 14th. There is a huge gap on the supply side. And OCC hopes to fill this gap, hopes to encourage new compute providers to come online. OCC hopes that with the larger players who are already serving in the compute market, there are smaller players who can get energized and who can actually play. It also hopes that customers who are actually growing in number, growing in type, can access these compute providers. This gap is only widening, as you'll see with other countries, and we have to catch up, right? So these are numbers from today. These are just going to amplify in the next 6 years. And you'll see there are gaps of 7, 10, 15, 25x when it comes to basic data center metrics as India fares against others. India's compute infrastructure today is really insufficient for our ambitions. If we we just heard from all these great leaders who are developing use cases pan-India in different walks of life. If we have to energize hundreds, thousands of such users, we have to energize the large talent pool that we talk about. Our infrastructure today is insufficient. And how do we make that sufficient? The idea is OCC. OCC is a grid that connects diverse compute. The thesis is that alongside global hyperscalers, domestic hyperscalers, there will be a long tail of smaller, agile, microcomputing providers who will exist, who should exist, who can connect into this open network, which will be running on standards and protocols, and customers should very easily come to this network, should be able to find compute providers based on their business needs, based on their geographic requirements, based on their budget constraints. OCC hopes to solve this problem. It's an open network for compute infrastructure. And the thesis is really driven by this, right? That one size will not fit all and should not fit all. There is no one compute provider who can satisfy everyone's needs and should not, right? There should be many, many more players. We should be encouraging new players to enter this market considering the amount of potential it holds for India. Now, the idea again is that if compute is the palette, customers on the other end are the artist. You sitting in the audience, right, are the artist. You should be allowed to mix and match different compute resources based on your requirements, and you should be able to do this very easily. It should not be hard for a customer, developer, or small startup today to find compute. And that's what OCC hopes to do in its first phase. It hopes to make discoverability of compute easy. Now, this grid is hoping to enable not just incremental, but exponential change. And there are 4 aspects to it. I covered access and choice, which means democratize access to more compute, easy compute, give you more options as a customer to compute not just from, and again, not just compute for all your workloads. Choose where your workloads want to go. If you want to put some on this on your own data center or on an edge solution close to you, do that. You should have that choice. But it also helps novel opportunities come to light. So for example, if you think of the solar grid and how net metering is done and how there are today providers who can give back to the grid, OCC is very similar. We need to encourage people to think about putting up compute infrastructure such that they could potentially give back to the grid after they've used it for their purposes in the downtime. That's one such idea, right? Compliance, security, data privacy, reliability, all are tenets of OCC. And those again are places where unique service providers could come out. And the last part is community. You know, and often when we think of compute, we think of that very tech-savvy developer sitting there who knows exactly what to do with the infrastructure. But just like Dharmesh said, there are a lot of people coming online. There are a lot of MSMEs who really don't know how to put up a website or how to develop an app for coming online. The community aspect is, I feel, a major one where there will be community-driven learning and development on OCC. And with this, in the next part of this evening, we present you this compute palette. Coming up next will be Vigyan Labs, a micro data center in Mysuru, then Von Neumann AI with their edge solution of cloud in a box, and then we present you the first look of the discoverability interface. Thank you.
Thanks, Tanvi. I'd like to introduce Srini Varadarajan from Vigyan Labs, who's building green micro data centers.
Vigyan Labs is a green, solar-powered micro data center located in Mysore, Karnataka. Founded by Srinivas Vandarajan and Srivatsa Krishnaswamy, the facility is compliant with global standards and has been operational for more than 3 years now. The Vigyan Labs team has automated an infrastructure stack of hardware and software innovations that have made the dream of a net positive, sustainable, and profitable data center reality. Vigyan Labs serves domestic and international customers in telecom, e-commerce, and BFSI.
Namaste, Vijayanand Gurudev here from Ishavasya Technologies, Mysuru. We run a company called Desi Cloud as well under Ishavasya, wherein we are associated with Vigyan Labs to be their sales implementation partner. We work with a lot of MSMEs in and around Mysuru as well as Bangalore, Mangaluru and other parts of Karnataka and also southern parts of India. We specialize in understanding what is the requirement of a very small customer so that we can help them with the appropriate sizing and also help them with the correct bandwidth they would need, because his website is only one page and he just needs that page for people to get connected and open up the leads for him. So we also have customers who are having around 20-30,000 concurrent users where they come in and they punch in orders and they do. So this is a spectrum with which we are working, from as low as 5,000 rupees per annum billing for a very small customer to 1.5 lakh rupees of billing per month. Many a times what we have understood is many of the startups spend about 40 to 70% of their total expenses on cloud infrastructure when they are actually not generating any revenue, or they might be generating a very little revenue. We also have a small saloon which is running their applications, the complete CRM we have developed for them. We have our own in-house applications being developed either for managing events or managing a small ERP for a small MSME, or be it multiple websites which are slightly dynamic in nature, which interact and they do the things. Hi, my name is Manjunatha KG and I am the founder and CEO at Agni Technologies Private Limited, a leading omni-channel marketing automation company. We operate under the brand Kensio. With a diverse clientele across the world like CaratLane, HDFC Life, Netmates, Swiggy and Zepto, we have been a satisfied customer of Vigyan Labs for 2 years now. Their pricing structure is very cost-effective compared to other major cloud providers. Their support has been excellent. This allowed us to scale our operations efficiently and invest in additional resources. Additionally, data privacy is a critical factor for us. With Vigyan Labs, our data remains within the country, giving us greater control and peace of mind regarding compliance and security.
Good evening, everyone. Next few minutes, I'll walk you through our journey of how to build a sustainable data center. First of all, behind every solution, there is a problem behind it. And what made us think about sustainable micro DC? It's almost 10 years, more than a decade back, when myself and a couple of us started designing the Aadhaar infrastructure. Then when we started putting large number of compute storage together, which consumes megawatts of power, we realized that globally, IT industry is one of the most polluting industries. Yes. In fact, data center, network, endpoints put together, pollute more than the aviation industry. It was an eye-opener for me, almost a decade back. So what we did was, once I just went back to Mysore, and I had a small team at the STEP Incubation Center. I got a small seed fund from the Government of India. Started researching on energy efficiency. What we found to our surprise, basically what people do is they use some applications to run our infrastructure, right? So shocking, the amount of energy consumed was not proportional to the work being done. That's where our research started. Over time, we have innovated. Our aim has been to make the data centers fully sustainable, using minimal amount of energy, use renewable power, but also consume very little water. Why this is important? Because a country like India, land is scarce, water is scarce, and we need to look at these two aspects, right? And what people traditionally do is, you put solar power, and you say, I'm green. And I'm sorry, just putting solar power is not green. You have to go beyond that one. A typical data center today, a large data center, if you're running an IT load of 1 kilowatt, to cool that, the traditional water-cooled chillers consume 2 liters of water. Now we're talking about gigawatt scale, gigawatt, terawatt scale. Just imagine the water. And people, Bangladesh, do you need water for drinking or for data centers to secure water? That's why our research began to build a sustainable data center. And we looked at micro DC because, as I told earlier, the land is a scarce commodity in India. If you simply want to go to solar, a 1 megawatt of solar plant requires 3.5 acres of land. Just like a solar grid on a rooftop, why can't we build a data center which is powered completely by the solar energy on the rooftop? A small size, small space, example, a quarter acre of land. Can you build it? Is it possible to do it? And I'm going to walk you through our journey, how we did it. One of the important things, why we need micro DC. Already Tanvi has talked about, why we need a micro DC and so on. There are many use cases for that, like, edge compute, autonomous computing, drones and so on. I'll not go into that much detail. I'll just talk about the next thing, what we did, right? This is a completely AI-driven building. This is in Mysuru. We did almost about 4 years back with this building. We have thousands of sensors running this building. There are no switches, electrical switches in the building. Completely sensor-based, AI-driven building. And we did a lot of innovation to make this happen, right? Just look at the bricks. Specialized bricks were constructed, so the cooling is almost reduced by 6 degrees in the building. And we use a little bit of cement, but still they made the building earthquake-proof. We have rooftop solar. And we had to cut down the energy consumption because this building could generate only 60 kV of power. In fact, our data center consumes less power than this building. So when you have a 60 kilowatt constraint, you have to re-engineer everything, reimagine everything. And what we created was like the Tesla of the data centers. We had to cut down everything, every watt, we had to make it count, and that's what we built it today. Just look at this graph. We are giving energy back to the grid. Many small shops near your home, retail shops, showrooms consume more energy than what we do today. Right? And we had to innovate many things, right? One of the things was, we had to cut down server energy consumption. On average, our servers consume about 150 watts of power. That's it. These are not small servers. Xeon Gold processor, a terabyte of RAM, and fairly high-end servers. And what our next biggest thing was cooling. How do you control cooling, right? How do you reduce the cooling? Typical traditional data centers have 1.5, 1.6, PUE, and they also consume water. We want to avoid water. What do? We took an air-cooled chiller and used AI to make it efficient. Today, our air-cooled chillers we use from third party, are more efficient than a traditional water-cooled chillers. That's why we are able to run at a PUE of just less than 1.3. Actually, our current data center today with about 10, 11 racks, the cooling load is less than your home air conditioner. And what kind of workload do you do? It's just not a bomb and a pop shop. We do run very complex workloads today. I just talked about earlier one of the case studies. Almost half of the country's notification messages go through data center today. We serve billions of messages every month through data center. But we also have India's largest pharma distributors in the cloud. And one of the largest customers we had onboarded initially in the earlier days was Technotree. I think you heard about them in the earlier discussion. There's a large telecom player, telecom infrastructure service provider, especially who have their OSS and BSS stack. We moved the workload from Finland to Mysuru. It was a big win for us earlier. And as the time progressed, we have customers of every small, medium, large, all sizes serving from this data center. And how did we just make this happen, right? It was not easy. I like to thank a lot of vendors, partners. In fact, somebody said, it takes 6 months to 1 year to build a data center. During COVID time, this data center was built in 3 months. We had 200 people working 24/7, 3 months to make it happen, go live. And a couple of notable things were, we had to work with Rishabh. They had to change their firmware to give us a special API to do energy analytics. Again, then we worked with Vertiv to integrate the chiller APIs with our AI engine to reduce the energy consumption of chillers. Then again, we worked with Daikin. Actually, we had to redesign the air conditioning itself for this building because we had kept only 10 kilowatt energy for air conditioning. A building of this 10,500 square feet would have required about 50 to 60 kV of energy for air conditioning. So we worked with Daikin for about 6 months to redesign the entire air conditioning. So Daikin was very cooperative. They redesigned the air conditioning to that. Today I'm glad to tell you that our air conditioner, the whole building air conditioning, other than the data center runs about less than 10 kV of load. So our typical load today with air conditioning, all the office load is less than 30 kV. And last but not least, I want to thank a few more vendors. Being in Mysore, it was not easy to get network connectivity. We had STPI and Tata Telecom, Tata was working with us, and they laid tens of kilometers of fiber for us, just for us. Thank you, Tata, Airtel, and STPI for doing a favor to us. Again, every other vendor like APC, HV, Standard, all of us. See, anything we put in a data center, it has AI, and we need an API. So every vendor complied with us, worked with us to create APIs for us to integrate our software. And that's where we are today, a green, clean data center. And hope we can share our experiences with all the other people who want to build green data centers and make this country, a zero water data center country, right? Thank you.
Thanks, Srini.
Just last. So how are we going to be part of OCC, right? So what we look at OCC as an enabling ecosystem for all micro data centers and large data centers to become part. So we have we have looked at a data center infrastructure, which is like a green data center. On top of it, we have the OCC APIs. Every data center participant will implement these APIs. And these APIs will be used by the OCC users to discover data centers of their size and need, right? It could be clean, green, I want GPUs, I want compute, I want storage. Consumers will be able to discover these data center services or cloud services, I call it, and then establish the contract and use them. And I see OCC as a way to accomplish our vision of going green, at the same time creating computing facility for every Indian, right? Thank you.
A big round for Srini. Thank you. So, up next we have Shashank. So he's going to tell us about something very interesting.
My name is Ankit Modi. I am a founding member of Cure.ai and I head the products team over here. Cure is world's most adopted healthcare AI. It is present in 90 plus countries across 2600 plus sites and has impacted 20 million plus lives with its products on radiology, AI and medical imaging analysis. We work on chest X-rays, chest CT scans, head CT scans and MSK X-rays. When we started Cure, we wanted to be the middle layer training large AI models. But what we realized was that AI was not enough. There was lack of digitalization in healthcare, and we had to work on workflows like QTrack and Cure app. Not even that sufficed to become successful. We realized that we were starting from India, and our target market at that point was the developing nations of the world, where compute was a major challenge. So we had to come up with our own unique solutions to deploy these AI solutions in settings where the access to internet was a challenge, access to compute was a challenge. If you want to start an AI company, India is the place to be. And then when you start out here, you are solving for challenges that are much more harder than what you would find in a developed country. When we started out, our target market was India, Southeast Asia, African nations, where all of these resources were very constrained around compute and internet. Solving that made it much easier for us to expand in the more developed parts of the world. It's like if you learn swimming in English Channel, coming back to swim in your society is not going to be a challenge. Now, solving for all of these challenges, Shashank Chilankurti, my good friend and a founding member of Cure.ai, was instrumental solving hardware. He worked significantly in optimizing our models and as well as optimizing the compute and hardware to make sure these solutions work in really low resource settings.
My name is Shashank, right? Hi, how are you guys doing today? Right? Hope you're having fun show so far, and I'm trying to spice it up more. So here, I'm starting up a new company called One Human AI. I was earlier founding member and CTO of Cure.ai, and I was also co-author of PyTorch, right? So Cure.ai is the world's most adopted healthcare AI, right? We have products in every body part, and we ended up deploying in a lot of places. We ended up deploying in Mount Everest, we ended up deploying in Nigeria, we ended up deploying in Assam, we ended up deploying in UK. So how did we do that, right? And healthcare, right? You have heard from briefcase, mera dodo kahi chira lega, right? So you need to take care of the privacy. So how did we do that? Well, we shipped compute. See, if we could not bring our customers to the cloud, we brought cloud to the customers, right? We sachetized AI and made it into small sachets and shipped it to our customers, right? What you see on the right is our product called QBox that we ship to our customers. This is our AI server that we ship to our customers, right? Today I'm looking to make this available to all the industries, all the companies out there, all the SMEs and startups who are looking to innovate in AI space. So introducing to you John A, right? I'm going to plug in right now, and I'm going to unveil the product. So as you can see, this is your personal AI server and runs off your normal grid supply. You do not require anything complicated. It's plug and play. It's super easy to use. As you can see, it's small footprint. I got it running in a freaking stage. Crazy, right? And it's free as in freedom. You're not logged into anyone. You're not logged into complicated ingress, egress costs. It's your data. It's physically lying with you, right? And it costs very reasonably at 2 lakhs, right? So a lot of people can afford this, right? So how does it work? It comes with what I call as your personal AI OS. It understands you and your business really well using AI. It comes with what I call as a cloud-in-a-box solution. So it comes with Ubuntu, which is what, like, if how many developers are here, they love Ubuntu, right? They love using Ubuntu to build their cloud apps. That's what everyone uses, not Windows. We all use Linux on cloud. So, well, not everyone knows Linux, so I have to shill for them. Well, like this also, it also comes with new GPL-approved softwares like Matrix, which is interoperable communication standard, so that like all the chatbots and whatnot can run on this standard. It comes with ERP Next, which most of you know is a Bangalore-based startup, creates a SAP alternative ERP. And it comes with a very open GPU computing stack called as One API. And it, of course, like we are talking in AI, right? It comes with LLMs built in. It's a proper cloud in a box. It comes with all the APIs that you need to build inside the freaking box, right? And STT, TTS, whatever you want. So how does it compare to public cloud? It's super competitive, right? So I'm comparing it to an equivalent public cloud instance. The AI speed is twice, right? You don't have to transfer your data anywhere. The data lies directly on the machine. right? Super secure because you're not taking away data anyway. It's on your box, right? And it's as easy to use, if not easier to use than a cloud, and it costs a fraction. It costs a fraction of what cloud does, right? I'm gonna show you how it works, right? In terms of cost. So let's assume you're an SME or just a startup that you're starting out right now. So you have an option of going with a public cloud, or you have an option of going with Jonic, right? So if you, so I have shown, I assume that you're scaling up as your users and you have bought a new server every year, right? So if you use a public cloud, I've taken metrics from a very famous public cloud and compare it to Jonic. So you'll break even in 3 months. And and if you buy another server in 12 months, it's just a small bump in your costs, while the the public cloud costs, goes up, right? Exponentially. So as you can see, by the end of 2 years, you'll have spent 4 lakhs on compute if you buy Jonic, but if you would have spent 25 lakhs on public cloud, right? Crazy stuff. So that's where I'm working with People+ai. So they are my first customer. So we are doing a demo. Outside. The machine that powers that demo actually sits in this building, in the 2nd floor. So if you come to the 2nd floor, I will show you the server as well, actually powering it up. So thanks, guys.
So the idea of OCC itself, we need to take a step back to understand why did we imagine the OCC as a possibility, first of all. One of the ideas that we have been working on, and some of them are successful, you are familiar with, is the idea of creating an open network of providers coming together, but network powered by protocols rather than a platform aggregating everything. So there is no one system need to aggregate. They can remain decentralized, but they can be discovered, transacted or contracted and transacted through a protocol. And that's a very, very interesting way, as big as internet, how internet was imagined through HTTP as a standard and HTML as a standard, protocols and standards that brought a decentralized millions of computers to a network, right? So quite similar to that. And OCC was also sort of imagined that same way, as saying we are going to have billions of devices and in one sense computing devices everywhere, and with IoT and with everything else, it's going to explode. But same thing is happening at a slightly higher order computing, not end devices like smartphones or IoT devices, but slightly larger server class. Many providers are not as big as a big cloud providers. Many of them are smaller. But we could have hundreds of smaller players. But if each of them have to behave like a mega player, then we have to create a network of micro players behaving like a mega network. So as Nandan once said, micro is the new mega. So OCC was conceived as a way to bring many micro data centers, micro computing environments, micro resource providers on a common network powered by common trust, common interoperability, common discovery protocols behind it. When we started doing this, we were asking, what's our first step? First of all, is there are we smoking something? Is there anything useful here? And we checked with many market players, and market players were resonating this idea. But the first step or egg step towards that idea was that let's bring them on a common network and make them discoverable. So discoverability of computing and storage and other data center resources as the first step is a brilliant way to get this started. And then you double click to negotiation, contracting, fulfillment, and so on. But one step at a time. I think it's a great way to bring it together. I am very excited about the possibility, what OCC can do.
In its overall vision, as of now, we envision OCC to be a network that allows providers of various kinds to be able to be discovered via a single decentralized network, as well as providing opportunities for consumers of all kinds of compute to discover and consume different kinds of resources, cloud and otherwise, through one single interface.
In these early days of open cloud compute network, I believe for consumers, OCC network will provide a credible and compliant set of providers on the network. And also, as we know that the consumers may not have all the expertise to build the cloud infrastructure or the architect a cloud solution, OCC can provide a community-driven development and community-driven learning to build a solution.
In the heart of Bangalore, Anand, a software developer, is building his first AI application in healthcare. Each iteration brings him closer to his goal, but the devil is in the details. His priority is to ensure that the AI runs on cost-effective data centers right here in Karnataka, aligning with the strict data compliance laws. But as Anand started looking at cloud resources available, he was uncertain and scared of messing up. The costs of utilizing GPU resources, even for a week, seem like a lot, and the geographic limitations threaten to block his work. Anand finds the Open Cloud Compute Network. He logs in and starts looking for compute resources based on his needs. To begin with, he types his requirements in the search box, say, set up Jupyter Notebook at a green data center in Karnataka. This brings up cards which allow him to install Jupyter Notebook environments across multiple providers. Each provider card has a location, usage cost, and even provides a green rating of that provider. It also includes SLAs promised by the provider. Anand selects the Vigyan Labs option in Mysuru since this OCC provider meets his needs. He clicks on his preferred resource and then on Get Started. The OCC network helped Anand discover and connect with a small and reliable provider in the market. He now has access to affordable and compliant compute at a location near him.
Just to sum it up, OCC for us is an initiative that could have global impact. Firstly, I want to acknowledge all the good work done by organizations sitting outside of India, thinking about how such a decentralized open network of compute infrastructure could be created. There are great organizations who've done great work, and we'll actually be engaging with them as we start developing and building this out. The second is global impact and usage of OCC. Nothing in this thesis limits OCC to only being used in India. It could serve global use cases, could help global applications being developed. And in our endeavor to actually build OCC, we have put together a consortium of 24 partners who came together today and had a historical meeting, the first of its kind market meeting, to actually discuss how OCC could be developed for India. We're very thankful to our partners who've come together and shown intent and shown the fact that they are looking to create an Adbhut India where compute is accessible to all. And last but not the least, I'd like to thank the OCC team. Everything that you've seen today about People+ai building OCC comes from this team. And I will just take 10 seconds if the OCC team members could just stand up for 15 seconds. I'm sorry to put you on the spot, but if you could stand up, right? All right. Please remember, with OCC, compute is a palette and you are the artist. Thank you.